Okay, just a few more words about ionic compounds. Remember, please, I know I keep bringing this up, but it's important that atoms aren't happy if they don't have a full valence shell. So that drives many things, including an atom's desire to gain or lose electrons when it ionizes. So all of this discussion of ionization is based on that statement. So let's take a look at another example, similar to the one that we did in the previous video, but just mix it up a little bit here. Let's pick a couple atoms off the periodic table. We're going to pick, for no particular reason, let's go with cesium. That's in column Roman numeral 1. And let's go with tellurium. That's in column Roman numeral 6. So just based on where they are, you should know how many valence electrons each of them has. So cesium is going to have one valence electron. A cesium atom might be drawn something like that, the one dot representing the one and only valence electron that it has. Tellurium is going to be in column Roman numeral 6, so it's going to have 6 valence electrons. So you might draw it out like this. The Lewis dot conformation, if you recall that, that just represents the valence electrons. Neither one of them is particularly happy with their status right now because neither one of them has a full valence shell. Cesium, of course, with just one valence electron in a shell that could hold 8, it's going to be inclined to throw away that one valence electron and become a cesium ion. What kind of ion? It's going to be a 1+ ion because you just threw away one negative thing and you kept all the same number of protons, so you're going to have a 1+ overall charge. Tellurium is just 2 electrons short of a full valence shell. This shell could hold 8, it's holding 6. So the convenient thing for it to do is to acquire 2 electrons and become an ion. But those electrons are negative. It just got 2 of them, so we're going to have a 2- charge there. So that's the way these two atoms will form their corresponding ions. The question is, what kind of a compound would form if you wanted to bind cesium and tellurium? In other words, if I told you there is an ionic compound that exists that is comprised of some cesiums and some telluriums, what would the formula of that ionic compound be? Well, to answer that question, you'd first have to do this. You'd need to know what the ions look like. You need to know that's a 1+, that's a 2-. And then all you have to do is put them together in a way that results in a 0 charge ionic compound. In other words, put these together in a manner so that all the positives cancel all the negatives. When you do that, and when you write the formula, please remember that you need to write what used to be the positive ion first when you write the formula out, and then what used to be the negative ion second. So I'll put that in here first, and then I'll say, okay, how many of each of these do you need? Well, tellurium has a 2- charge. One of them has a 2- charge. One of these has a 1+. I'm going to need 2 of these for every one of those. I'm going to need this to be a 2-to-1 ratio. I need 2 cesiums to cancel the charge of 1 tellurium. So I'm going to put the subscript 2 right there. So 2 of these for every one of those. I don't write the number 1 here. Please do not write the number 1. It is not correct to write number 1. It is implied, so we're going to get rid of that number 1 because it shouldn't be there. So that's the formula for an ionic compound that is comprised of cesium and tellurium. Cs2Te. Again, notice that that 2 is subscripted. It's not written like that. It's written below, indicating that there are 2 of these that are part of this entire compound. And that's another example of ionic compounds. We're going to put some practice problems up there for you to try.